The most exciting part of the class is watching me set up the camera. Okay. 48. Oh yeah.
Oh yeah, I got that.
Oh yeah. This is one. This is a good example of like a problem that's really pushing it. If I remember correctly. All right. Gather all my belongings. Ferris wheel. Oh yeah, this is so good. Sorry. All right. Yeah. So. I'm not going to talk about this one yet because I have a feeling not everybody's tried the more basic problems. This one is one that will push you a bit. Yes.
Yeah.
The most important thing is to draw this correctly, and one thing that people miss is that it's 1 meter above the ground is how you get on it.
That's the other thing is that that was the main thing is that I had no idea how to draw the thing.
Like I did like a circle and then I did 25 like this and then it said 6 o'clock. So then I did this and then 10 minutes was the period because that's the time. Well, I mean,
Yeah, one full cycle in 10 minutes, so the period is 10 minutes.
And I did like a random line at the bottom of the circle that said 1 meter. And then
Random line. Oh, sure. So that's 1 meter, and then the circle starts. Sure.
yeah.
Okay.
And then I don't know how bright my mom is, but she said amplitude equals radius.
That's
And then
right.
it tells us the diameter, so then I did.
Yeah. Now think about it. Why does that make sense? Amplitude totally equals radius. If you think about so real quick. So if I have a circle, the midline is right down the center. So isn't that where I'm at 0?
Yeah.
And then I go up to the maximum, which is a radius away. And then when I get to the minimum, isn't that a radius away? So the radius is the amplitude, and the midline is through the center, right? Where we normally draw the diameter. But the midline has been pushed up 1 because it's 1 meter off the ground, right? Okay.
So that's a vertical shift.
And then
Yeah.
I was confused when it said midline because it's not like I can see it. So then like there was a formula that said the midline equals the y max plus the y min.
So guys, so here, help me out. This whole thing is 1 meter off the ground, correct? So here's a circle, here's the Ferris wheel, here's the ground, this is 1 meter. What's the diameter?
25.
25. So what is this mark? How far off the ground is this?
26 meters.
26. Right? So it goes from 1 to 26. The midline is the number that's in the middle of 1 and 26. Yes? No? If I have a sine function that goes from 1 to 5, right? What's the midline?
4,
No?
3.
Why is it 3?
I
I don't know if you guys are like 4, 3, 2. Come on.
Because the amplitude is 4.
Because 3 is
Or it's
equidistant
2.
from either side,
The
right?
amplitude is 2.
What's 1 plus 5?
4.
What's 1 plus 5?
6.
6 divided by 2. 3. Of course it is, because how do you find the middle of any two numbers? Average them. So what is the midline if it goes from 1, yes, to 26? What's the midline? Average 1 and 26. Be careful.
13.7.
Okay, that's better. Not really, but the other way. So how do you average 1 and 26? Add them.
And then
Divide
divide by 2.
by 2. Yeah. Okay. Can't remember what I just said. Yeah, that's right. Okay.
I already
Maybe.
got that one.
All right.
But
Sorry, go ahead.
Can I ask?
And then from there, you could figure out the amplitude because it's just the distance from the middle to either side, right? Okay. So I'll give you guys a head start on that problem. Yeah.
So, I'm not asking for you to work out all these problems, but
why not?
You can ask.
the 27, 24, 27, and 30, can you just like...
The same section, I guess?
You can pass it.
I know, I was just looking at the instructions. Oh, that's not for them, I guess. Oh, this is its own thing. So 24, oh. Okay.
So like,
All right, let's start off with where is the midline?
You're looking at,
How can you very quickly tell it's not 0? Does it get equidistant from 0 in both directions? Yeah, you don't have to guess. How high does it get? 2. How low does it get? -4. How do you average those two? 2 plus -4 is -2 divided by 2, -1. How do you check how far away does -1 is the maximum? I think I heard it. 3. And how far away is the minimum? 3. Do you see that? And that's what the midline's supposed to be. It's supposed to be the middle line. So I just told you what the amplitude is also, right? Maybe? Do you guys get that? What is the amplitude of a sine or cosine function? Can somebody define that for me? Amplitude of a sine or cosine function.
it's how far from the absolute value, just from the midline.
You just say distance, because distance implies absolute value. So it's the distance from the midline to either extreme. It's how far away it gets from the midline. You guys follow? I can always find the midline because I can just average the extremes, because that'll make it right in the middle. And then I just see how far away does either side get, right? I could also figure out the amplitude directly by just how far apart are 2 and -4, 6, divide that in half, 3. That's the amplitude.
So, did we look at 27 here?
to
I don't-
find the period, would you have to?
Locate a cycle, and there's a lot of different options here, right? I can either look at this like, now it would be more difficult to do a cycle like sine starts at 0. I really want you to understand. Here's a cycle, correct? Here's the maximum. When's the next time it hits that? There. That's a cycle. You can figure out the period. Yes?
Is the distance away from the cycle? Is that what
The
you're saying?
cycle is how long it takes for it to go. The cycle is just a complete. It gets all the way through all of its motions. So here it is at the top. Then it goes down. Then it goes up, and then it's going to repeat down. So the minute it starts to repeat what it did before, that's the end of the cycle. So one quick way to find a cycle, sometimes, depends on how it's lining up, is to look at two maximums and see how far apart they are. So a cycle, let's see.
When you're finding the period, are you looking at the distance between each cycle?
What's the period?
Pi.
No. I mean, what's the definition of the period?
Oh.
How long it takes?
How long it takes for one cycle to complete. So you have to visually find a cycle. The easiest cycle I can see up here. Because sine starts at the midline, correct? You guys with me? And then it goes to a maximum, and then it goes to a minimum, and then it goes back to the midline. Since the midline's offset, it's a little bit harder to do. So I'm going to do like a cosine. Cosine starts at the max, goes down, and then comes back up. So that's this. Max, down, back up. That's the period.
Oh,
That's how long it takes to go through one cycle. What's it going to do right after that? Starts at 0. What's it going to do right after this? It's going to repeat that same shape again, correct? That's when the cycle starts over. When the wheel of time turns. Okay. So let's see. Mike, you said something about 27.
Yes.
It's the same. Oh, this guy.
So
Let's
the
see if you
issue that
guys-
I'm having right now is.
Well, real quick. Let's get everybody caught up.
Fine.
Try to do what I just did. Why can't I do like a max to max? Because they didn't tell me what that is, correct? So instead of max to max, try min to min. So here's a min. I know exactly where it is. Next min. I know exactly where it is. So what is the period? What would I do with these? Subtract them. Good. Then I'll know the period, right? And that's one of the harder parts of this problem, because where's the midline for this? It's kind of nice. Where's the midline?
Smack in the middle. It's on
Zero,
the x-axis.
right? Y equals 0. So the amplitude is easy to see, yes? Yes.
So then how would you start out writing the equation for that?
So let's see, what are they? Oh, they tell me it's a cosine. That's important. So, one little thing that's going to be a little difficult here is the phase shift, right? And they don't even ask you to find the phase
Exactly.
shift, but
That's what I was having
yeah.
trouble with.
So I know it's going to be 4, right?
Yeah.
4 cosine. The phase shift is not as difficult to see as you might think necessarily. Let me see how I can point this out. You could do it, Jeff. Yeah. What does cosine normally do? At 0, where does it start?
It goes down.
So it starts at 1, yes? Normally for normal cosine, right? Let's see if you guys. I could either say it's been shifted to the right. You see that? But then do I know what this is? No. Yeah, I can say it's been shifted back. Oh, I know what that is. So how much has it been shifted back? By pi over 2. So what's that mean is going to be in, so here's k, we'll come back to that in a minute. What's that mean is going to be in here? Yeah, good.
Okay, so here's.
So now I just got to figure out what k is.
Here's the problem I'm having with that. I mean, like, isn't it supposed to have like the y-axis in the middle of one of them waves?
That's right, and that's exactly how we just figured out how much been shifted. If it's supposed to start here, how much did they push it back? Yeah.
Oh,
So if I push that back pi over 2, it actually starts where it's supposed to. So we push
Okay.
it. Now, again, just to make sure you understand, I could have said, oh, they shifted it over by some amount, but do I know what that is? No. So then I go, okay, well, they shifted it back some amount. Okay, I know what that is.
what I was thinking is like where that line for the -2 plus pi over 2, that was where it was supposed to have been because it's been flipped.
Okay, you could totally do that too. You could actually say, it's been flipped, and you could say that it's been pushed back by this much.
And
I
I
would-
would put all those numbers in.
I would rather not.
Oh.
I don't have to. I want you to, couldn't you say that somebody flipped it and then pushed it back this much? Do you guys see that?
Yeah.
That is a total option. The math doesn't give a shit. Either way, it would work out to be the same thing. So I'd much rather go, let's not flip it, let's just, okay, so they just pushed it back by pi over 2.
That's better, because what I tend to forget is that this goes like
Yeah.
from negative infinity
Yes.
all the way to infinity,
Yeah.
and it's just the same thing.
So how many possible answers are there for this?
Probably
An infinite number. They all mathematically come down to the same thing. They all mathematically equal the same thing. So I'm just going to do it the easiest way I can see how. Yeah.
So if we know the period before we know k, could we divide the period by?
How do you always find the new period?
5
Yeah, I'm sorry, I got to be careful.
Oh, you
For
know the
cosine,
fractions?
2 pi over k, correct?
Yeah.
What did we say the period was?
It was
The new period.
minimum minus 2 minus each other.
Yeah. So figure out what that is and put that number here and solve for k. If I know k, I can calculate the new period, correct? If I know the new period, I can calculate k.
So you
Algebra, I just need to have everything except for one number, and then I can solve for it, right?
So then you put the period that we do have where 2 pi is.
Well, no, careful. That is the normal period for cosine. That will never change for cosine or sine. What will change is the value of k, which will change what the period is. You can figure out what the period is, and you could put that number here. Solve for k. Yeah. Okay. And that's the one last thing we need for this to be done. Yeah.
So we
Why?
Because it's -2 plus pi over 2.
Oh, okay. I need to get the equation that would create that entire picture.
So is that like a point, basically?
That's a point. Yeah, that's part of a point. That's a specific value of x. My answer has to have x in it so that I can plug whatever the hell I want to in it. Otherwise, I don't get the entire graph. I just get 1 point. Yeah.
And in order to find k, do we have to do -2 plus pi over 2 minus pi over 2?
Other way. Big minus small. Does it make sense? Big minus small, right? If I said how far apart are 1 and 5, you wouldn't say 1 minus 5, so they're -4 apart. It's big minus small, right? So period is just if you can see a cycle, how far apart is the beginning and the end, period. Period. It's the period. Okay. So, let's see. You can do it, Jeff. Anybody need an updated homework sheet? So, just to remind everybody, I will work on this over the weekend to finish this, and you will be very happy to give me time to do that because what I'm doing is cutting down on some of the homework. Like any damn time you want to, Jeff. So 10 is in purple because that's as far as I got so far, just to remind myself. The dates have changed. The homework in chapter 9 has changed a bit because we're just not going to get as deep into some things, which is, the way it is. And then I think I made one or two extra credit sections. I can't remember, or I don't remember. Okay. All right. Everybody see the quiz on Monday, right? Okay. So let's get back into where we left off. I desperately want to give you guys a little worksheet to try out, but I just want to review real quick. And you have to turn this on to do that, Jeff. Everything is so needy. How you guys doing, by the way? You guys all right? This is not, so I just want you to know, everybody here has access to mental health care. Just so you know. Including me, which is good. Right? Dear God, if you're feeling overwhelmed, even not just by me necessarily, but I'm probably not helping, you do have access to mental health care. And I've got the information up in Canvas. It's on the student support. You can go to the student support hub. The success coach is always a great place because they're just connected to every damn thing. So if you call a success coach and you say, this is what's happening in my life, and they'll go, talk to this person and this person, here's a phone number, here's your email. You guys with me? So you're never floating on your own. You're always, thankfully, you've got some program that can help you with whatever you're experiencing. Okay. If your problem is me, go see my chair, tell them Jeff needs some correction. I joke about it, but I'm a human. I'm if I do shit that I don't even know is bad, like cuss. But too bad for you. I'm not gonna damn well stop cussing. Okay. So just a quick review. Can anyone tell me inverse sine? This is one of the hardest things for us to remember, but inverse sine. What is the domain? Do I want the domain? I want the range. Sorry. Yeah, negative pi over 2 to pi over 2. Inverse cosine, range. So you can always have in your head, you can always have, like for sine, here's sine, correct? Mm-hmm. So the range to make this invertible, I can't go here. I've got to go from this to this. So that's negative pi over 2 to pi over 2. Then it would be invertible, right? That piece in the middle, that would pass the horizontal line test. Cosine goes like this. So I definitely can't use negative pi over 2 to pi over 2. That would suck. So instead I use 0 to pi. This would be invertible, correct? So that's 0 to pi. And we had a little discussion about if the problem is such that there's supposed to be a specific quadrant your answer shows up in, Poor little, the only way this dude could exist is if we don't let him give me answers except from the fourth to the first quadrant. You guys see what I'm saying? Because if the answer is supposed to be in the second quadrant, I have to kind of adjust it to put it there. It's giving me a reference angle, right? Okay, so one immediately nice consequence of having inverse trig. What's the answer to an inverse trig? Physically, geometrically? Angle. The input for a trig is an angle, the output for an inverse trig is an angle, because they flip those. So if I tell you this is something we would have never been able to do before now, and I say, what is this? What is C? Am I thinking right? No, Jeff. Good job, buddy. That's something we could have done before. Let me try this again. This is what I wanted to do. There it is, Jeff. Look at you go. I want angle B. This other one we could have done all day. That's just a straight up normal trig. How do I get angle B? Well, what's a trig function that relates what I know to this angle?
Sine B, so it would be inverse sine of B.
Yeah, so to solve this, I would take the inverse sine of both sides. Die. So I get B is the inverse sine 7/11. And then you would just throw that in your calculator. Okay.
That's really cool.
All right. Well, cool. I like that reaction. I don't get that very often. How about, and then we looked at a question like this. Inverse sine of, nope, Jeff. Today's just the second attempt kind of day. So what I really want you guys to kind of like take in. Do you see how this triangle led to this statement?
Yes.
Therefore, math almost always goes both ways. You can all be jealous. So that means if I give you this statement, it would lead right to this triangle. So see, that's a sine I'm talking about, right? So whatever the angle is, the sine of it should be 7/11. So the y is 7 and the hypotenuse is 11. So what triangle does this create? Yeah, so what's y? 1. What's x? 3. And now I'm just asking for the sine of this angle. Again, remind me, what is this physically, geometrically? An angle. So this is a sine of the angle whose tangent is 1/3. So if I just draw the triangle it's talking about, I can answer the question quick. Well, not immediately. What do I have to do to answer this question? To get the sine I need? R. 1 squared plus 3 squared. 1 plus 9, 10. So the sine would be?
Square root 10.
Careful.
Or, sorry, 1 over square root 10.
Which is?
Square root 10 over 10.
Ta-ba! Good. Okay. So here we go. I'll give you this. This side, do not worry about it yet. I want the one with the green triangle, right? This side with the green triangle. The man with one red shoe. Do the side with one green triangle. You got my reference. As always, you can work together if you want to. If you don't trust any of these people, then just work by yourself. Oh, you're gonna need. I'm gonna kind of catch up to you a little bit. Can somebody tell me what's the first thing you did for this triangle? Sure. Okay. What's this angle?
53.
Kick ass, because you know it's got to make 180 total. So these two have to make 90. Kick ass. And then
It's
sine 37 equals
y over 14.
y over 14.
Multiply.
And real quick, again, young Jeff said, okay, sine is the percent of the hypotenuse that's in the y direction. Not a true statement, but it doesn't matter because it's sort of, so like this percent of 14 is in the y direction. It's kind of a nice way to go straight to here. Do you have to do that? No, you're fine. Look here, sine 37 is the y side over the hypotenuse, multiply by 14, you got there. Okay. And then whatever the hell that comes out of the calculator looking like.
8.42.
Okay. And again, on an actual test or quiz, that'll tell you how many decimal places to go to. Couple's pretty good when in doubt. All right, keep going. Just make sure we're on the right track. Because now you got two different things you can do to get the last side.